Um, Hi everyone, my name is Clyde. My project is about applied parallelization approach in Wi-Fi 6 generation network driver design. So before going to the main part, I'd like to quickly talk about the relationship between the computer network and operating system. So as we know, the OS can be considered as a medium between the user and the hardware. It allows user to interact with a computer either by clicking on things or writing the code without having to deal with the hardware directly. But when we need to interact with the external hardware, like connecting to other device or server, we need to use the computer networking module in the operating system. And how they run inside the computer can be very different. For example, let's say we want to visit a website like Moodle. From the perspective of the operating system, user have to start with the application layer, which can be simply considered as what we operating on the screen. We type in the URL to send a request, and this request is then processed to the down to the OS in kernel level at there, which resolve the URL into the actual IP address of the Moodle server and down to figure out which network interface card which have to use. And then the data will be packaged and sent out through the hardware, and when it reaches to the Moodle server, the package goes through the reverse process of being unpackaged. So that server understand we want to visit Moodle, and it can then handle the things like logging us in or an upload or download the file or something else. So in reality, the responsibility of developing the product are clearly separated. For example, user just can focus on using the application like web, apps on the phone, and the OS developer focus on building the operating system. But the interesting is that when we go all the way down to the data link layer and the physical layer, the design and development of this part are usually handled by the company who make the hardware on this. So each company has different design, and its design leads to a few problems. First, is generic hardware design leads to conservative driver implementation. Companies that design Wi-Fi device need to ensure the compatibility with wide range of operating systems like Windows, Mac OS, and various versions of Linux. And besides, they also have to consider computing units in the system, such as CPUs and its architectures. So not to mention that this operating system and hardware have multiple versions and use cases. So because of this, their designs tend to be very conservative. For example, they often stick to the single thread models and rely on the efficient data structure to ensure the compatibility and the stability across different platforms. And the second is, as I just said, the Wi-Fi device cannot really take advantage of multi-core CPUs to boost network performance because of the conservative design. So in the end, this kind of safe design become a big bottleneck in this product. So why is it important? As I mentioned earlier about the performance bottleneck, if we set aside hardware issue and just look at the system design, the bottleneck is actually at this driver. And this driver also plays a really important role in how well we upper layer perform. Take the Wi-Fi 6 as an example. The theoretical speed is about 9.6 gigabyte per second. However, even in the best signal condition, most Wi-Fi device cannot reach half of the theoretical speed, and in some cases, companies even admit their maximum speed is only 20 to 30% of it compared to the theoretical speed. And another reason is that about feasibility. For us, hardware is something we cannot change. And on the other hand, up to the upper layer, it is possible to modify the operating system kernel, but it's not easy. And OS modules are really large. I have tried it. Just compiling it might take over an hours, whether the result is fail or success even has some chance to break the computer. So the software layer is the best for student. is flexible and safe enough for us to work with and optimize it. And so let's narrow down into how the network packets are processed in the data link layer. When the package comes in, the hardware like network card will receive from the air of the package and do some bitwise check, signal calculation, and make sure everything is okay. And after that, the package gets handled off to the driver module in the OS for process that data link layer. So once that's done, it goes up to the kernel layer and finally go to the process to see real data and payload. But there's a problem. After looking at the Wi-Fi driver design from several big companies like Intel, Realtek, and MediaTek, and I felt that they follow the minimal design and maximum compatibility to get their product compatible with everything. So because of this, they tend to be used serialized and single thread design. And that creates a lot of issue. Here's a detailed process of packet processing. So once major problem is that any small delay or blocking in one part of this process will affect everything that comes after and before it. So in a single thread model, once something gets stuck, the whole package pipeline will start slowing down until the blocking place release the resource. So throughput will reduce as well. So what I want to do is introduce the multi-producer consumer model to parallelize the processing of these packets. So in terms of the workflow, I would first try single producer, single consumer, and then multi-producer, single consumer, and finally multi-producer and multi-consumer to see which setup gives the best performance. For my experiment setup, I'm using two personal computers. One acts as the client to send the data, and the other as a server to receive it. Those computers will establish a TCP connection using the tools called IPv3. With the client sending the traffic to server, I will have the server to act as a Wi-Fi hotspot and have the client connect to directly. For execution time and output, I'm not using the traditional runtime to measure it, and I will analyze the output provided by this tool. And there are two main network performance metrics I care about the most. And the first is throughput, which measure how much data can be received per second. And the second is latency, the average delay for each packet. So ideally, I want higher throughput and a lower latency as much as possible. So in terms of actual setup, I'm using Realtek Wi-Fi card along with the open source firmware inside the Linux kernel. The experience includes 5 main steps. The first is modify the firmware code and compile it and remove the original firmware embedded in the kernel and insert the new compiled binary file back to the kernel and connect to Wi-Fi and start testing. As for validation, I rely on the performance output from IPv3 since it's record exactly the metrics and I need to evaluate the changes. My first goal is to optimize the performance. Even a 5 to 10% improvement is already significant for me. The second goal is to see if it's possible to go beyond the vendor advertised speed, although I'm not sure if there's even achievable. It is something worth, but it is still worth to try. And here's my reference. And I do some related work on the Google Scholar. Um, has anyone done similar optimization? Yes, definitely, but they all chain modified it on the Wi-Fi 4 and Wi-Fi 6.5. And but why it is still different now? Because the Wi-Fi start update approximately 5 years, and then it's about Wi-Fi 7 is released. So every generation, the hardware, driver logic, and package formats will change a lot. So it's still worth it to try it. Thanks for everybody. Thanks.